What's up, everybody? This is Mike, Super Mike 2164, putting up some science information on the BU1 Math Science channel. One of the things that we have to understand when we're dealing with subjects in the world, in order to understand where you've been lied to, some of the fundamental spots where you've been lied to, you have to first of all, be able to question. And you have to understand some basics of science in order to even be able to question. Because if someone tells you a lie and you have no understanding or background in the subject they're talking about, you really don't have a ability to even raise a question. So, we can always start off asking questions why. Okay. And then in order to ask more intelligent questions, we go to investigating the actual subject. So I want to know time. Okay, we are dealing with authorities. Authorities lie. Authorities mislead. Authorities make mistakes and they don't want to admit their mistakes. And sometimes you don't even understand why would they lie. What is their purpose? Because you have no idea of what's going on. So, the age of the universe, the age of things, how do these people know how old something is? They told us the universe was 13 billion years old. So, they told us the planet was about 4 billion years. Let's read this here. National Geographic, which is a respected authority. The examination. How did scientists calculate the age of the Earth? The examination and analysis of rocks on the Earth's surface and of extraterrestrial rocks have enabled scientists to determine the approximate age of the planet. So they expect us to go out to grades 3 through 12. At that age, once you get information, you don't even think to question it. Why would you even question it at that age? So let's go some more. Turn this music down a little bit. So let's look at it. Thermal ionization mass spectrometer. What's that? That's what this is. Thermal heat ionization mass spectrometer. The age of rocks is determined by radiometric dating, which looks at the proportion of two different isotopes or types of the same element in a sample. Radioactive isotopes break down in a predictable amount of time, enabling geologists to determine the age of a sample using equipment like this thermal ionization mass spectrometer. Take a look at a globe or a map of the world, and you may be impressed by what you see: towering mountains, deep oceans, vast continents, and sprawling glaciers. They make Earth what it is today. Even more impressive, by some people's standards, is the age of the Earth. Scientists have calculated the age of our planet to about 4.5 billion years. But how do scientists determine that age? The answer is complicated. Okay. It involves everything from observation to complicated mathematics to understanding the elements that make up our planet. In the 1800s, as scientists sought to determine the age of the planet, they made a few missteps. In 1862, a famous Irish physicist and mathematician, Kelvin, estimated that the Earth was between 20 million and 400 million years old. While that is an enormous span of time, even an age of 400 million years would make the planet quite young in relation to the rest of the universe. Kelvin, I won't call him Lord, okay? But, that's their word. Kelvin based his conclusions on a calculation of how long it would take the Earth to cool if it had begun as molten mass. You see? And this right here is where I want to get at. Notice a couple things here. As we are the reader, we want to question. If we're scientists, we're reading scientific information. You don't just accept at face value everything. Your question should be, how could this be wrong? How could they have made a mistake? First of all, look at the mistake this guy Kelvin made. He made an assumption that if the Earth begun as a molten mass, he doesn't know how that was done. What was around it? Okay. If the Earth had began at a molten mass, so they're making assumptions too, because so let's keep going. All right. And also they're only telling you about the estimate of Kelvin in the 1800s. What did the black people say the age of the Earth was? What did the Asians, the Indians, the Rig Vedas, what were they saying the age of the Earth was, and why? And how did they get their numbers? What did the Australians say? What did the Chinese or the Asian what did everyone else say? We only care about what the Western scientists calculate. So that right there, we should be understanding that we're missing a lot of information. And we're delegitimizing every other group. So this guy, Kelvin, based his conclusions on a calculation of how long it would have taken Earth to cool if it had begun as a molten mass. While his estimate was wrong by a significant margin, his technique of drawing conclusions based on observations and calculation was an accurate scientific method. How do you know it was accurate? How do you know? Because see, they assume that their calculation is correct. What is your method as compared to others' methods? Okay. And how is this verifying with all other known information? So scientists also try to use relative dating techniques to determine the age of the planet. Stratigraphy compares the configurations of layers of rock or sediment in order to determine how old each layer is in relation to one another. This technique can reveal which layers are older or which events happen before the others if the layers of sediment have remained in sequential order. Layers can be rearranged, bent, or contain inconsistencies. However, stratigraphy yields no exact age for those layers or events. Nonetheless, even though this technique did not give scientists the precise number they were looking for, it did suggest that the Earth was most likely billions of years old and not just millions, as was previously thought. Now, keep in mind, this is the 1800s. They're moving up in their techniques. Okay, so we see guessing. And keep in mind, they just started us off in this understanding of age, how to tell time. They just started us off in the 1800s with Kelvin guessing. Okay, they didn't go into any other culture or any other thing, or who said what, but they just start off with their own guesses based upon what they see and believe, thought, okay, and what they could think of. So as advances in chemistry, geology, and physics continued, scientists, keep in mind, this is white scientists, Western scientists. Scientists found a method by which the absolute age and actual number of years of a rock or mineral sample could be determined. This method is called radiometric dating. Okay. And it involves the decay or breakdown of radioactive elements. Using radiometric dating techniques, it became possible to determine the actual age of a sample. Radiometric dating requires an understanding of isotopes. Isotopes are variations of an element differentiated by the number of neutrons in their nuclei. The isotopes of unstable radioactive elements, known as parent isotopes, eventually decay into other more stable elements, known as daughter isotopes, in a predictable manner and in a precise amount of time, called a half-life. The half-life of an element is the amount of time required for exactly half of a quantity of that element to decay. The age of a sample can be determined based on the ratio of parent to daughter isotopes within the sample. One problem with this approach to dating rocks and minerals on Earth is the presence of the rock cycle. Now let's see how they address this. Because we know that we have volcanoes. We know that we have induction of the Earth's crust into the mantle and recycling of rocks, which takes billions of years by itself. These continents look real stable, but they're actually moving under the earth, getting recycled. Okay. So during the rock cycle, rocks are constantly changing between forms, going back and forth from igneous to metamorphic to sedimentary. Old rocks may even be destroyed as they slide back into Earth's mantle to be replaced by newer rocks formed by solidified lava. This makes finding an exact age for the Earth difficult because the original rocks that formed on the planet at the earliest stages of its creation are no longer here. The older rocks that have been found are about 3.8 billion years old. So some tiny minerals have been dated to at 4.2 billion years. Okay, so let's say how they get around this. And keep in mind, this is 4.2 billion years is about the age that they tell us the planet is. And what do we mean by age now? That's what we got to think about. Are they talking about the current age of the rocks that they can test? Or are they actually talking about how many times this planet has recycled itself? They don't know how many times have all the rock cycles happened. How many cycles? Okay. To get around the difficulty presented by the rock cycle, scientists have looked elsewhere in the solar system for even older rock samples. Okay. So basically, they're saying, okay, let's go somewhere else. They have examined rocks from the moon. Okay. And from meteorites, neither of which have been altered by the rock cycle. The same techniques of radiometric dating have been used on those rocks. All the data from Earth and beyond has led to the estimate age. Okay. Now keep in mind, so they're showing that also that the moon was part of the Earth, but anyway. So all the data from the Earth and beyond has led to the estimate age of 4.5 billion years for our planet. All right, so that's how they figured out the Earth. Now they really didn't. They left a lot open. Where did they leave open? Like I said, they never talked about the any other culture and how they got the age of the universe or age of the Earth. They also left out like you know, are there any limits of this radiometric dating cycle? Keep in mind also they're saying that the ones on the Earth they got at about have been dated about 4.2 billion years, and are there any holes in that? How long has the moon rocks been dated? Which the moon was a part of the Earth because they have the same makeup. So, like I said, that's their way of figuring out things. Their rock cycles, they can't really tell, but it's still in guess mode. So, this is what we need to understand. That's all I want us to understand. We just need to make sure that we're questioning. When you read scientific things, you just don't just, oh, that's it. This is just what they know at this point in time. It's still a guess, even though they present things as if it's pretty much said and done and they know for a fact, but not really. So, how old is the universe? So, this is how they figured out how old the age of the universe is. This is how they believe. So you never ask a cosmic being its age, but if that cosmic being encompasses all space, time, and matter, you could get a little curious. Scientists have long been curious about the age of the universe and how much time has elapsed since the Big Bang. Now, they just guessed this Big Bang thing. Today, scientists estimated that the age of the universe is approximately 13.8 billion years old. To me, these are very small numbers. But how did scientists estimate how old the universe is? And are they sure of that number? It all comes down to ancient stars and ever-expanding cosmos. How did astronomers calculate the age of the universe? Okay. To estimate the age of the universe, scientists rely on two main methods: calculating the expansion of the universe, determining the ages of the oldest stars. So the Hubble constant, since its conception, the universe has been expanding at an accelerating rate. The universe's expansion is known as the Hubble constant, which is estimated at 46,200 miles per hour. Wow. 46,200 miles per hour per million light years. Oh, miles per hour? Is that mph? Wow, that's interesting. Per million light years. The Hubble constant was first calculated in 1920s by American astronomers. See, they like to keep their old stuff as if this man can calculate the expansion with no mistakes the first time. Okay. So Edmund Hubble, he calculated this in 1920s. He discovered several galaxies were moving away from Earth. I mean, 46,200 miles per hour per million light years. That's interesting. Hubble also noted that the further a galaxy was, the faster it was moving. It looks like some relatively problems, or maybe an illusion based upon your position. Hubble also noted that the further a galaxy was, the faster it was moving away. Based on Hubble's observations, the astronomer came up with Hubble's law, which showed a correlation between how far an object is and the speed at which it's receding. Now, it could just be cycling around a core, and just based on your position, a thing that's closer to us will move at a tighter orbit. A thing that's further away will look like it's moving at a faster orbit. Scientists were then able to use the Hubble constant to estimate the age of the universe by working backwards, all the way back to the Big Bang. This extrapolation depends on, these are just guesses. These are really just guesses based upon the first man to observe what he's seen, the little part he's seen, and that's it. And then they just calculate and work backwards. All right, so Hubble's law. Scientists were able to estimate the expansion of the universe. Scientists were then able to use the Hubble constant to estimate the age of the universe by working backwards all the way back to the Big Bang. This extrapolation depends on current density, and density is mass times volume. Mass, do you have all the mass times the volume that you see? Okay. Current density and composition of the universe, which shows the history of its expansion. In 2012, NASA's Wilkinson Microwave Anisotropy Probe used that data that they typed into it to estimate the universe's age to be 13.772 billion years, give or take 59 million years. That's it. Okay. A year later, the European Space Agency's Planck spacecraft estimated the universe's age to be 13.82 billion years. Okay. Keep in mind, this is just based upon the information that they just seen and Hubble's estimation of his perception. Okay. And the mass that they're able to see. Keep in mind, they couldn't see all the mass times the volume that they were able to see. Okay. So ancestral stars, another way to determine the age of the universe is to look at the oldest stars. The universe can't be younger than its oldest stars. Okay. Therefore, to narrow down the age, the oldest stars, the thing is, there could have been stars that were born and died. The oldest stars, that's crazy. There's a cycle of death and life, okay, that goes just over trillions of years, I'm sure. Okay, the oldest stars that they see. Therefore, so they can be younger than its oldest stars. Therefore, to narrow down the age of the universe, scientists measure the age of the very first stars that formed in the cosmos. The life cycle of a star depends, see, it's a life cycle. So they can see a cycle, depends on its mass. With high mass stars burning fuel at a faster rate and therefore dying out faster, while low mass stars can live up to 20 billion years. Wait a minute, low mass stars can live up to 20 billion years, but the universe is only 13.7 or 82 billion years old, really. Okay. So they're saying that these things can live up to 20 billion years. How do you know that? Okay. Globular clusters are dense stellar collection of around 1 million stars, which all form roughly around the same time. These clusters can then serve as timekeepers for the universe. By determining the masses of their stars, scientists can estimate when the globular cluster formed. The oldest globular clusters contain stars that are 0.7 times less massive than the sun, which suggests that they all suggests that they are between 11 to 18 billion years old. So at least has to be 18 billion. Okay. All right. So that's just giving us some ideas there. The thing is, here's some other, ideas of why. See, the universe, the heat, there's a problem with the expansion of the universe, the way that they're talking with this Hubble stuff. Space is all the same temperature. Is that a coincidence? Distant patches of the universe should never have come into context, so according to Hubble. So how come they're all just as hot as each other? The temperature of the cosmic microwave background, the radiation bathing all of space, is remarkably uniform. It varies by less than 0.001 degrees from a chilly 2.725 Kelvin. And that's named after the scientists who tried to estimate the planet, right, at 400 million years. But while that might seem natural enough, the consistency is a real puzzle. For two widely separated areas of the cosmos to reach thermal equilibrium, heat needs enough time to travel from one to the other. Even if this happened at the speed of light, the universe is just too young for this to have happened. Cosmologists try to explain this uniformity using the hypothesis known as inflation. It's a hypothesis. So this means that when they present it with a piece of information, a fact, in science, you can't just dismiss facts. Even if it seems like it's relatively small, it must be explained, everything. And this here throws a wrench inside Hubble's crap. And it throws such a wrench in it, it needs to be thrown away. Hubble's estimation needs to be thrown away, but that would send them to square one. They don't know how old the universe is, but they got to have an answer for you. Cosmologists try to explain this by uniforming the hypothesis known as inflation. It replaces the simple idea of a Big Bang. Now, see, that right there knocks the Big Bang out, with the one in which there was also a moment of exponential expansion. This sudden, faster than light increase in the size of the universe allows it to have started off smaller than an atom, when it would have had plenty of time to equalize its temperature. So really, they just kind of, when they're presented with information, they just kind of guess, figure, but I guess that's the best they can do. So these are all just theories, but they present them as facts almost, and want to argue about something they have no idea about. On the face of it, inflation is a totally bonkers idea. It replaces a coincidence with a completely nonsensical vision of what the early universe was like, says Andrew Ponson at University College in London. Yet it seems to work. The sudden expansion would also help explain why the observable universe appears flat. The universe is flat. Sounds like when the planet was flat. Much as the curvature of the Earth only becomes visible when viewed on a large scale. Space-time's complex geometry might appear flattened to observers only viewing a fraction of the whole. So I think that's where we'll end off today. Like I said, we're just getting some ideas out here. The universe is complicated. It's not something that they could just figure out in a few hundred years and they just have all the answers. That's pretty much where I wanted to go with this. We just want to be questioning people. We don't want to just, just because we don't know something or we have not seen something, it did happen. We need to know what we don't know. We need to get all information. Check out all the origin stories of everybody on the planet. There's people there's 78 trillion. How they get that? How do they prove that? Very old. Trillion. All right, guys, that's it.